Picture this, a world where factories no longer dot the Earth's surface but float gracefully in the vast expanse of space, crafting materials and technologies that were once thought impossible. Imagine a future where the limitations of gravity no longer bind us, where the raw materials of asteroids and moons fuel industries, and where the stars themselves become the backdrop for humanity's greatest innovations. This isn't science fiction, it's the future of space-based manufacturing, and it's closer than you think. In this video, we'll take you on a journey through 30 groundbreaking predictions that could redefine how we build, create, and thrive, both on Earth and beyond. From zero-gravity 3D printing to self-replicating machines, these ideas aren't just dreams, they're the blueprints for a future that's waiting to be built. So, buckle up and get ready to explore the incredible possibilities of space-based manufacturing, where the next industrial revolution might just happen among the stars. Now let's dive into our first prediction, zero-gravity 3D printing. Imagine a world where the constraints of gravity no longer limit what we can build. In the weightlessness of space, 3D printing takes on a whole new dimension, allowing us to create structures that would be impossible to manufacture on Earth. Without gravity pulling materials down, we can print intricate, large-scale designs with precision and ease. Think about spacecraft components or even entire habitats, crafted layer by layer in orbit, using lightweight yet incredibly durable materials. These structures wouldn't just be stronger, they'd also be more efficient, reducing the weight and cost of launching materials from Earth. This isn't just about building better tools for space exploration, it's about redefining what's possible in manufacturing altogether. From massive space stations to interplanetary vessels, zero-gravity 3D printing could be the key to unlocking humanity's next great leap into the cosmos. And as we look ahead, this technology could even pave the way for constructing entire cities in space, where the only limit is our imagination. Now, shifting our focus to the next groundbreaking prediction, let's talk about in-situ resource utilization, or ISRU. Picture this, instead of hauling every single material we need from Earth, we could mine and process raw materials directly from asteroids, the moon, and other celestial bodies. This approach would revolutionize space-based manufacturing by making it self-sustaining and far more efficient. Imagine landing on an asteroid rich in metals like iron, nickel, and even rare elements like platinum. Advanced robotic systems equipped with cutting-edge mining tools could extract these resources, while processing units would refine them into usable materials right there in space. The moon, with its abundance of oxygen and water ice, could become a key supplier for life support systems and fuel production. Technologies like autonomous drilling rigs, chemical processing plants, and even 3D printers designed to work with extraterrestrial materials would be essential. By tapping into these off-world resources, we could drastically reduce the cost and complexity of space missions, enabling longer stays and larger-scale projects. This isn't just about saving money, it's about creating a sustainable infrastructure that supports humanity's expansion into the solar system. From building habitats to fueling spacecraft, in-situ resource utilization could be the backbone of our interplanetary future. And as we develop these technologies, we'll not only unlock the potential of space, but also gain valuable insights into resource management that could benefit Earth. The possibilities are as vast as the cosmos itself. Now, let's take a leap into the next frontier of space-based manufacturing, orbital factories. Imagine factories not on Earth, but floating in orbit, harnessing the unique conditions of microgravity to produce cutting-edge materials and components. These orbital factories could revolutionize industries by manufacturing high-tech products like semiconductors, advanced alloys, and even ultra-pure crystals materials that are incredibly difficult or impossible to produce on Earth. In microgravity, the absence of gravity-driven forces like sedimentation and convection allows for the creation of materials with unprecedented precision and quality. For example, semiconductors made in space could have fewer defects, leading to faster and more efficient electronics. Similarly, advanced alloys produced in orbit could be stronger, lighter, and more durable, perfect for aerospace and other high-performance applications. But the benefits don't stop there. Moving heavy industry off-planet could have profound economic and environmental impacts. On Earth, industrial processes often come with significant pollution and resource depletion. By shifting these activities to space, we could reduce the strain on our planet's ecosystems while tapping into the vast resources of the solar system. Orbital factories could also lower the cost of space exploration by producing essential components and materials in orbit, eliminating the need to launch everything from Earth. This would make missions more sustainable and scalable, paving the way for larger projects like space stations, lunar bases, and even interplanetary travel. And let's not forget the potential for innovation. Orbital factories could become hubs for experimentation, where scientists and engineers test new manufacturing techniques and materials in ways that simply aren't possible on Earth. From cleaner production methods to groundbreaking discoveries, the possibilities are endless. As we look to the future, orbital factories could be the key to unlocking a new era of technological advancement and environmental stewardship, both in space and here on Earth. Now, let's shift our focus to an idea that could redefine how we power our world: space-based solar power manufacturing. Picture this: massive solar arrays built in orbit, capturing sunlight 24 hours a day, free from the limitations of weather, nighttime, or atmospheric interference. These orbiting power plants could generate clean, limitless energy, beaming it back to Earth or supplying it to space colonies. The key to making this vision a reality lies in space-based manufacturing. Constructing such enormous structures on Earth and launching them into space would be prohibitively expensive and logistically challenging. But by manufacturing these solar arrays directly in orbit, we can overcome these hurdles. In microgravity, engineers could assemble lightweight, ultra-efficient solar panels and deploy them on a scale that's simply impossible on Earth. These panels could be made from advanced materials, designed to withstand the harsh conditions of space while maximizing energy output. Once operational, these solar arrays could transmit energy to Earth using microwave or laser technology, providing a constant, reliable source of clean power. This could revolutionize our energy infrastructure, reducing our dependence on fossil fuels and helping combat climate change. But the benefits don't stop there. Space-based solar power could also support long-term space exploration and colonization. Imagine lunar bases or Mars habitats powered by orbiting solar arrays, ensuring a steady supply of energy even in the most remote locations. And as we expand further into the solar system, these power stations could become the backbone of an interplanetary energy grid, enabling sustainable exploration and settlement. The potential is staggering, not just for energy production, but for the broader impact on humanity's future. By harnessing the power of the sun in space, we could take a giant leap toward a cleaner, more sustainable future, both on Earth and beyond. Now, let's take a step into the realm of self-replicating machines. A concept that sounds like science fiction but could soon become a cornerstone of space-based manufacturing. Imagine machines that can build copies of themselves entirely autonomously without human intervention. These self-replicating machines would revolutionize how we approach manufacturing in space. Instead of relying on costly and time-consuming resupply missions from Earth, these machines could use raw materials found in space like metals from asteroids or regolith from the Moon to create new versions of themselves. This would drastically reduce the need for transporting heavy equipment from Earth, making space manufacturing more efficient and sustainable. The implications are enormous. Once the first self-replicating machine is deployed, it could create an entire network of manufacturing units, exponentially increasing our capacity to produce tools, habitats, and even spacecraft in space. This would enable rapid expansion of infrastructure, whether it's building lunar bases, constructing space stations, or preparing for missions to Mars and beyond. The ability to replicate themselves also means these machines could adapt to new challenges, repairing or upgrading their own systems as needed. But how would this work in practice? These machines would likely rely on advanced robotics, artificial intelligence, and modular design principles. They would be programmed to identify and process raw materials, assemble components, and then replicate their own structure. Over time, they could even evolve to perform more complex tasks, such as constructing entire habitats or mining operations. This would not only accelerate space exploration, but also pave the way for a self-sustaining industrial ecosystem in space. The potential for self-replicating machines extends beyond manufacturing. They could play a critical role in disaster recovery on Earth, rapidly producing emergency supplies or infrastructure in hard-to-reach areas. And as we venture deeper into the solar system, these machines could become the backbone of interplanetary industry, ensuring that humanity has the tools and resources needed to thrive in the cosmos. The development of self-replicating machines represents a leap forward in our ability to harness the vast potential of space, transforming the way we build, explore, and sustain life beyond Earth. As we look ahead, the possibilities are as limitless as space itself. Next, we'll explore how space-based manufacturing could revolutionize another critical area: the production of advanced materials that are impossible to create on Earth. Now, let's shift our focus to something truly extraordinary: the potential of space-grown materials. In the unique environment of microgravity, scientists and engineers are discovering that materials can grow in ways that are simply impossible on Earth. This opens up a world of possibilities for creating substances with unparalleled purity and precision, revolutionizing industries from medicine to technology. One of the most exciting examples is the growth of ultra-pure crystals. On Earth, gravity causes imperfections in crystal structures as they form. But in space, the absence of gravity allows for the creation of crystals that are nearly flawless. These ultra-pure crystals have incredible potential in fields like electronics and optics, where even the tiniest imperfections can affect performance. Imagine faster, more efficient computer chips or more powerful lasers, all made possible by materials grown in space. But it doesn't stop there. Space environments also offer unique opportunities for bioengineering. Researchers are exploring how microgravity can be used to grow bioengineered tissues, such as human organs or muscle fibers, with greater precision and complexity than ever before. This could lead to breakthroughs in regenerative medicine, providing new treatments for diseases and injuries that are currently untreatable. For example, space-grown tissues could be used to create more effective skin grafts for burn victims or even entire organs for transplant patients. The applications extend beyond medicine. Space-grown materials could also revolutionize manufacturing processes here on Earth. For instance, the production of advanced alloys or composite materials could benefit from the unique conditions of microgravity, resulting in stronger, lighter, and more durable products. These materials could be used in everything from aerospace engineering to renewable energy systems, pushing the boundaries of what's possible. What makes this even more exciting is the potential for scalability. As space-based manufacturing becomes more accessible, the ability to grow these materials in orbit could lead to a new era of innovation. Companies and researchers could collaborate to develop new products and technologies, all made possible by the unique properties of space-grown materials. As we continue to explore the possibilities of space-based manufacturing, it's clear that the growth of unique materials in microgravity will play a pivotal role in shaping the future. From ultra-pure crystals to bioengineered tissues, the potential applications are vast and transformative. Next, we'll dive into how space-based manufacturing could revolutionize another critical area: the production of life-saving pharmaceuticals. Now, let's turn our attention to a groundbreaking frontier in space-based manufacturing, the production of life-saving pharmaceuticals. Imagine a future where some of the most effective medicines are not made on Earth, but in the unique environment of space. The absence of gravity in orbit opens up possibilities that could transform how we develop and deliver drugs, potentially saving countless lives. One of the most promising areas is protein crystallization. On Earth, gravity often disrupts the formation of protein crystals, making it difficult to study their structures in detail. But in microgravity, proteins can crystallize more uniformly, allowing scientists to analyze them with unprecedented precision. This could lead to the development of new drugs that target diseases more effectively, from cancer to Alzheimer's. For example, space-grown protein crystals could help researchers design medications that bind more precisely to specific molecules in the body, reducing side effects and improving treatment outcomes. Another exciting possibility is the development of advanced drug delivery systems. In space, the absence of gravity allows for the creation of unique materials and structures that could revolutionize how medications are administered. Imagine tiny, space-manufactured capsules that release drugs at a controlled rate, ensuring patients receive the exact dosage they need over time. This could be a game-changer for treating chronic conditions like diabetes or heart disease, where precise dosing is critical. The benefits of space-based pharmaceutical production extend beyond individual treatments. By manufacturing drugs in space, we could also reduce the environmental impact of pharmaceutical production on Earth. Many drug manufacturing processes generate harmful waste or require large amounts of energy. Moving these processes to orbit could help create a more sustainable approach to medicine, benefiting both people and the planet. What's truly remarkable is how quickly this field is advancing. Companies and researchers are already experimenting with space-based drug production, and the results are promising. As access to space becomes more affordable, we could see a surge in space-manufactured pharmaceuticals, bringing these life-saving treatments to patients around the world. The potential of space-based pharmaceutical production is immense, offering new hope for treating diseases and improving global health. From more effective drugs to sustainable manufacturing practices, the possibilities are as vast as space itself. Next, we'll explore how robots are set to play a crucial role in assembling the future of space infrastructure. Now, let's shift gears and explore a future where robots take center stage in building the infrastructure of space. Picture this: massive structures like space stations, lunar bases, and even interstellar spacecraft being assembled not by human hands, but by advanced robotic systems. These space construction robots are set to revolutionize how we build beyond Earth, tackling challenges that would be nearly impossible for humans alone. One of the biggest advantages of using robots in space construction is their ability to work in environments that are too hazardous or inhospitable for humans. For example, assembling a lunar base would require precise welding and heavy lifting in low gravity, tasks that robots can perform with unmatched accuracy and endurance. These machines could operate tirelessly without the need for life support systems or brakes, making them ideal for long-term construction projects in space. But it's not just about strength and precision. Space construction robots will also be equipped with advanced artificial intelligence, allowing them to make real-time decisions and adapt to unexpected challenges. Imagine a robot detecting a structural flaw in a space station module and instantly recalibrating its tools to fix the issue. This level of autonomy will be crucial for building complex structures in the vast, unpredictable environment of space. Another exciting possibility is the use of swarms of smaller robots working together to assemble large-scale projects. These robotic teams could collaborate like a well-oiled machine, each unit performing specialized tasks to achieve a common goal. For instance, one group of robots might focus on welding, while another handles material transport, and yet another inspects the quality of the work. This collaborative approach could dramatically speed up construction timelines, making ambitious projects like interstellar spacecraft more feasible. The impact of space construction robots extends beyond just building structures. They could also play a key role in maintaining and repairing existing infrastructure. Imagine a fleet of robots patrolling a space station, identifying and fixing issues before they become major problems. This proactive maintenance could extend the lifespan of space habitats and ensure the safety of their inhabitants. As we look to the future, it's clear that space construction robots will be indispensable in our efforts to expand humanity's presence in the cosmos. From assembling lunar bases to maintaining interstellar spacecraft, these machines will be the unsung heroes of space exploration. Next, we'll dive into how space-based recycling systems could create a sustainable future for off-world habitats. Now, let's turn our attention to a critical aspect of sustainable space living: recycling. In the vast emptiness of space, resources are precious and waste is not an option. Future space habitats will rely on advanced recycling systems to transform waste into valuable resources, creating a closed-loop manufacturing ecosystem that ensures nothing goes to waste. Imagine a space station where every piece of trash, from food packaging to broken equipment, is processed and repurposed. These recycling systems will use cutting-edge technologies to break down waste into its basic components, such as metals, plastics, and organic matter. These materials can then be reused to manufacture new tools, equipment, or even building materials for expanding the habitat. This approach not only reduces the need for resupply missions from Earth, but also minimizes the environmental impact of space exploration. One of the most exciting possibilities is the recycling of water and air. In space, every drop of water and every breath of air must be carefully managed. Advanced systems will filter and purify wastewater, turning it back into clean drinking water. Similarly, carbon dioxide exhaled by astronauts can be converted back into breathable oxygen through chemical processes. These closed-loop systems will be essential for long-term missions, ensuring that life support remains stable without constant resupply. But recycling in space goes beyond just water and air. Future habitats will also recycle metals and other materials to create new products. For example, old spacecraft parts could be melted down and reshaped into new components, reducing the need to launch heavy materials from Earth. This not only saves costs but also makes space missions more sustainable by reducing the amount of debris left in orbit. Another innovative aspect of space-based recycling is the potential to turn organic waste into useful resources. Food scraps and other biodegradable materials could be processed into fertilizers for space-grown crops, creating a self-sustaining food production system. This would be a game-changer for long-term missions, providing fresh food while reducing the need for packaged supplies. The benefits of space-based recycling extend far beyond sustainability. By creating a closed-loop system, we can reduce our reliance on Earth's resources and make space exploration more self-sufficient. This approach will be crucial for establishing permanent settlements on the Moon, Mars, and beyond, where resupply missions are impractical or impossible. As we look to the future, it's clear that recycling will be a cornerstone of space-based manufacturing. From turning waste into valuable resources to creating self-sustaining ecosystems, these systems will ensure that humanity can thrive in the harsh environment of space. Next, we'll explore how space-based manufacturing will support the growing space tourism industry, creating luxury experiences beyond our planet. Now, let's shift our focus to an exciting frontier that combines innovation with adventure: space tourism. As humanity ventures further into the cosmos, space-based manufacturing will play a pivotal role in shaping the future of luxury travel beyond Earth. Imagine a world where orbiting factories produce state-of-the-art spacecraft, lavish habitats, and even entertainment facilities designed to make space tourism an unforgettable experience. One of the key contributions of space-based manufacturing will be the production of luxury spacecraft tailored for tourists. These vehicles won't just be functional, they'll be designed with comfort and style in mind. Picture sleek, spacious interiors with panoramic windows offering breathtaking views of Earth and the stars. Advanced materials manufactured in space will make these spacecraft lighter, faster, and more energy efficient, ensuring a smooth and enjoyable journey for passengers. But it's not just about the journey. Space-based manufacturing will also create luxurious habitats for tourists to stay in. Imagine orbiting hotels with zero-gravity lounges, gourmet space kitchens, and even artificial gravity zones for those who prefer to keep their feet on the ground. These habitats will be constructed using materials sourced from space, reducing costs and making them more sustainable. From private suites to communal observation decks, every detail will be crafted to provide an unparalleled experience. Entertainment will also take on a whole new dimension in space. Space-based manufacturing will enable the creation of unique attractions, such as zero-gravity sports arenas, immersive virtual reality experiences, and even spacewalks for the adventurous. These facilities will be built in orbit, offering tourists activities that simply aren't possible on Earth. Imagine playing a game of basketball where the hoop floats in mid-air, or watching a concert with Earth as the backdrop. These are the kinds of experiences that will define space tourism. The economic impact of this industry will be enormous. Space tourism will create new jobs, from spacecraft designers to hospitality staff trained for zero-gravity environments. It will also drive innovation as companies compete to offer the most luxurious and memorable experiences. And with space-based manufacturing reducing the costs of production and transportation, space tourism could become more accessible to a wider audience over time. As we look to the future, it's clear that space-based manufacturing will be the backbone of the space tourism industry. From crafting luxury spacecraft to building orbiting hotels and entertainment hubs, these advancements will transform how we explore and enjoy the cosmos. Next, we'll dive into how artificial intelligence will revolutionize space-based manufacturing, taking automation and efficiency to new heights. Now, let's turn our attention to a game-changing development that will redefine how we think about manufacturing in space: the rise of artificial intelligence-powered factories. Imagine a future where space-based manufacturing facilities are not just operated by humans, but are driven by advanced artificial intelligence systems capable of making decisions, optimizing processes, and even learning from their own experiences. This is not science fiction, it's the next logical step in the evolution of space-based manufacturing. Artificial intelligence will play a crucial role in making space factories more efficient and autonomous. In the harsh and unpredictable environment of space where human presence is limited, AI systems will take charge of managing complex production lines. These systems will monitor every aspect of the manufacturing process, from material extraction to final assembly, ensuring precision and minimizing waste. For example, AI could analyze data from sensors in real time to adjust machinery settings, predict equipment failures before they happen, and even reroute production tasks to avoid delays. One of the most exciting possibilities is the ability of AI to optimize resource usage. In space, where every gram of material is precious, artificial intelligence will help factories operate with maximum efficiency. It could determine the best ways to recycle materials, reduce energy consumption, and even design products that use fewer resources without compromising quality. This level of optimization will be critical for long-term sustainability in space, where resupply missions are costly and infrequent. But AI's role won't stop at efficiency, it will also enable innovation. By analyzing vast amounts of data, artificial intelligence systems could identify patterns and suggest new manufacturing techniques or materials that humans might not have considered. For instance, AI could discover novel ways to combine materials in microgravity, leading to the creation of products with unique properties that are impossible to produce on Earth. This could open up entirely new industries and applications, from advanced electronics to groundbreaking medical devices. Another key advantage of AI-driven factories is their ability to adapt to changing conditions. Space is full of uncertainties, from fluctuating temperatures to unexpected debris. Artificial intelligence systems will be able to respond to these challenges in real time, making adjustments to keep production running smoothly. This adaptability will be essential for maintaining operations in remote locations, such as lunar bases or deep space outposts, where human intervention is not always possible. The integration of artificial intelligence into space-based manufacturing will also have a profound impact on Earth. The technologies and processes developed for space factories could be adapted for use in terrestrial industries, leading to smarter, more sustainable manufacturing practices worldwide. From reducing carbon footprints to improving supply chain resilience, the benefits of AI-powered factories will extend far beyond the stars. As we look ahead, it's clear that artificial intelligence will be the driving force behind the next generation of space-based manufacturing. By enabling autonomous decision-making, optimizing resource usage, and fostering innovation, AI will transform how we produce goods in space and ultimately how we explore and settle the cosmos. Next, we'll explore how space-based manufacturing will revolutionize another critical aspect of life beyond Earth: food production. Now, let's shift our focus to something that's essential for any long-term mission in space: food. Space-based food production is set to revolutionize how we sustain ourselves beyond Earth, and it's not just about packing freeze-dried meals anymore. Imagine a future where astronauts and space colonists enjoy fresh, nutritious meals grown right in orbit or on distant planets. This isn't just about convenience, it's about survival and sustainability in the most challenging environments imaginable. One of the most exciting developments in this area is the rise of hydroponic and aeroponic farming systems. These methods allow plants to grow without soil, using nutrient-rich water or mist instead. In the microgravity of space, these systems can be optimized to use less water and energy while producing higher yields. Picture floating greenhouses orbiting Earth or nestled inside lunar bases, filled with leafy greens, vegetables, and even fruits. These farms won't just feed astronauts, they'll also provide psychological benefits, offering a touch of nature in the otherwise sterile environment of space. But it doesn't stop at plants. Lab-grown meat is another game-changer for space-based food production. Scientists are already working on cultivating meat from animal cells without the need for raising livestock. In space, this technology could provide a sustainable source of protein without the logistical challenges of transporting live animals. Imagine enjoying a juicy, lab-grown steak on Mars, produced in a compact bioreactor that fits inside a space habitat. This innovation could eliminate the need for traditional farming methods, making it a perfect fit for the resource-constrained environment of space. Another fascinating possibility is the use of 3D printing for food production. Space-based manufacturing could enable the creation of customized meals tailored to individual nutritional needs. Using ingredients like powdered proteins, carbohydrates, and fats, 3D printers could assemble meals layer by layer, ensuring variety and balance in astronauts' diets. This technology could also incorporate vitamins and minerals to address the unique health challenges of living in space, such as bone density loss and muscle atrophy. Sustainability will be at the heart of space-based food production. Closed-loop systems will recycle waste into nutrients for plants, creating a self-sustaining ecosystem. For example, carbon dioxide exhaled by astronauts could be captured and used to enhance plant growth, while organic waste could be composted to enrich the growing medium. This circular approach will minimize the need for resupply missions and ensure that space colonies can thrive independently for years or even decades. The impact of space-based food production won't be limited to space. The technologies developed for growing food in microgravity and resource-scarce environments could have profound applications on Earth. From urban vertical farms to sustainable protein sources, these innovations could help address global food security challenges and reduce the environmental footprint of agriculture. As we look to the stars, it's clear that space-based food production will be a cornerstone of humanity's future in space. By combining cutting-edge technologies with sustainable practices, we can ensure that astronauts and space settlers have access to fresh, nutritious food, no matter how far from home they are. Next, we'll explore how space-based manufacturing will transform another everyday necessity, the clothes we wear. Now, let's turn our attention to something that might not immediately come to mind when thinking about space-based manufacturing, the clothes we wear. Space-based textile manufacturing is poised to revolutionize how we produce fabrics and materials, creating possibilities that are as practical as they are groundbreaking. Imagine space suits that are not only stronger and more durable but also lighter and more flexible, or habitats lined with textiles that can withstand the harsh conditions of space while providing comfort and insulation. One of the most exciting prospects is the development of ultra-strong fibers in microgravity. On Earth, gravity can limit the quality and strength of certain materials, but in space, the absence of gravity allows for the creation of fibers with unparalleled durability. These materials could be used to craft spacesuits that offer better protection against radiation, micrometeoroids, and extreme temperatures, all while being lightweight enough to allow for greater mobility. This could be a game changer for astronauts, enabling them to work more efficiently and safely during spacewalks or planetary exploration. But it's not just about spacesuits. Space-based textile manufacturing could also produce lightweight, high-performance fabrics for habitats and spacecraft interiors. Imagine walls lined with materials that are not only fire-resistant and radiation-shielding, but also breathable and comfortable. These textiles could help regulate temperature, reduce noise, and even improve air quality inside space habitats, creating a more livable environment for long-term missions. Another fascinating application is the production of smart textiles fabrics embedded with sensors or other technologies that can monitor health, adjust to environmental conditions, or even generate energy. In space, where every resource is precious, these advanced materials could play a crucial role in enhancing the efficiency and safety of missions. For example, a spacesuit equipped with sensors could track an astronaut's vital signs in real time, alerting them to potential health issues before they become serious. The benefits of space-based textile manufacturing won't be confined to space. The technologies developed for creating these advanced materials could have significant applications on Earth. From high-performance sportswear to protective gear for hazardous environments, the innovations born in space could transform industries and improve everyday life. Even the fashion industry could see a revolution, with designers using space-manufactured fabrics to create garments that are both functional and futuristic. As we continue to push the boundaries of what's possible in space, textile manufacturing will play a vital role in ensuring the safety, comfort, and efficiency of those who venture beyond our planet. By leveraging the unique conditions of microgravity, we can create materials that are stronger, lighter, and more versatile than anything we've seen before. Next, we'll explore how space-based manufacturing will transform another critical aspect of our lives, the electronics we rely on every day. Now, let's shift our focus to something that powers nearly every aspect of modern life: electronics. Space-based electronics manufacturing is set to redefine how we produce the devices and components we rely on daily. In the unique environment of space, free from the constraints of gravity and Earth's contaminants, the potential for creating higher-performing, more reliable electronics is immense. One of the most significant advantages of manufacturing electronics in space is the absence of gravity. On Earth, gravity can cause imperfections in the production of delicate components, such as semiconductors and microchips. In microgravity, however, materials can be processed with unparalleled precision, resulting in electronics that are faster, more efficient, and less prone to defects. This could lead to breakthroughs in computing power, enabling devices that are smaller yet far more capable than anything we have today. Another key benefit is the reduction of contaminants. Earth's atmosphere is filled with dust, moisture, and other particles that can interfere with the manufacturing process, especially at the microscopic level. In the pristine environment of space, electronics can be produced with extreme purity, enhancing their performance and longevity. Imagine smartphones, satellites, or medical devices that last longer and operate more reliably thanks to components made in space. Space-based manufacturing could also revolutionize the production of specialized electronics for space exploration itself. For instance, spacecraft and satellites require components that can withstand extreme temperatures, radiation, and vacuum conditions. Producing these components in space ensures they are perfectly suited for the environment they'll operate in, reducing the risk of failure and extending the lifespan of critical systems. But the impact won't stop at space exploration. The advancements made in space-based electronics manufacturing could have far-reaching implications for industries on Earth. From healthcare to telecommunications, the ability to produce ultra-reliable, high-performance electronics could drive innovation across the board. Think of medical devices with enhanced accuracy, or communication networks with faster, more stable connections, all powered by space-manufactured components. As we look to the future, space-based electronics manufacturing represents a leap forward in how we design and produce the technology that shapes our lives. By harnessing the unique conditions of space, we can create electronics that are not only more advanced but also more dependable, paving the way for a new era of innovation. Next, we'll explore how space-based manufacturing will transform another critical area: energy storage systems that could power both space missions and life on Earth. Now, let's turn our attention to a critical challenge that affects both space exploration and life on Earth: energy storage. Space-based manufacturing is poised to revolutionize how we produce advanced energy storage systems, such as supercapacitors and batteries, unlocking new possibilities for efficiency and sustainability. One of the most exciting prospects is the ability to manufacture energy storage devices in microgravity. On Earth, gravity can interfere with the precise layering and assembly of materials needed for high-performance batteries and supercapacitors. In space, however, these materials can be arranged with incredible accuracy, resulting in energy storage systems that are more compact, powerful, and durable. Imagine batteries that charge faster, last longer, and store more energy, all thanks to the unique conditions of space. Another advantage lies in the materials themselves. Space-based manufacturing allows for the production of ultra-pure materials, free from the impurities often found on Earth. This purity can significantly enhance the performance of energy storage systems, reducing energy loss and improving overall efficiency. For space missions, this means lighter, more reliable power sources that can support longer journeys and more ambitious exploration goals. On Earth, it could lead to breakthroughs in renewable energy storage, making solar and wind power more viable and accessible. Space-based energy storage systems could also play a crucial role in supporting future space habitats and colonies. Advanced batteries and supercapacitors produced in space would be essential for storing energy generated by solar arrays or other power sources, ensuring a steady and reliable supply for life support systems, research equipment, and more. This self-sustaining energy infrastructure would be a cornerstone of humanity's expansion into the cosmos. But the benefits don't stop there. The innovations developed in space-based energy storage could have a profound impact on Earth's energy landscape. From electric vehicles to grid-scale storage, the ability to produce more efficient and sustainable energy storage systems could accelerate the transition to a cleaner, greener future. Picture a world where energy is stored and distributed with unprecedented efficiency, reducing waste and lowering our reliance on fossil fuels. As we look ahead, space-based energy storage represents a transformative opportunity to address one of the most pressing challenges of our time. By leveraging the unique environment of space, we can create energy storage solutions that are not only more advanced but also more sustainable, paving the way for a brighter future both on and off our planet. Next, we'll delve into how space-based manufacturing could revolutionize the production of cutting-edge medical devices, opening up new possibilities for healthcare innovation. Now, let's shift our focus to an area where space-based manufacturing could truly transform lives: the production of cutting-edge medical devices. Imagine a future where the tools and technologies used to diagnose and treat diseases are manufactured not on Earth but in the unique environment of space. This isn't just science fiction, it's a possibility that could revolutionize healthcare as we know it. One of the most promising applications is the creation of microsurgical tools. In microgravity, the precision required for manufacturing these delicate instruments can be achieved with unparalleled accuracy. On Earth, even the slightest imperfections caused by gravity can affect the performance of surgical tools. But in space, these tools can be crafted with microscopic precision, enabling surgeons to perform procedures with greater control and less risk. Think about the implications for complex surgeries, where even a fraction of a millimeter can make all the difference. Another exciting possibility is the production of advanced diagnostic equipment. In space, the absence of gravity allows for the creation of ultra-pure materials and components, free from the contaminants that can interfere with sensitive medical devices. This could lead to the development of diagnostic tools that are more accurate, reliable, and efficient. For example, imaging devices like MRI machines could be enhanced with components manufactured in space, providing clearer and more detailed scans. This could lead to earlier detection of diseases and more effective treatments. The unique conditions of microgravity also open the door to innovations in drug delivery systems. Devices like implantable pumps or targeted drug delivery mechanisms could be manufactured with greater precision in space, ensuring that medications are released exactly where and when they're needed in the body. This could improve the effectiveness of treatments for chronic conditions like diabetes or cancer, offering patients better outcomes and a higher quality of life. But the benefits of space-based medical device manufacturing extend beyond individual patients. By producing these devices in space, we could reduce the costs and environmental impact associated with traditional manufacturing processes. Space-based facilities could operate with minimal waste and energy consumption, creating a more sustainable approach to producing life-saving technologies. This could make advanced medical care more accessible to people around the world, bridging gaps in healthcare access and affordability. As we look to the future, the potential for space-based medical devices is truly inspiring. From microsurgical tools to diagnostic equipment, the innovations made possible by microgravity could redefine what's achievable in healthcare. By leveraging the unique environment of space, we can create medical technologies that are not only more effective but also more accessible, paving the way for a healthier future for all. Next, we'll explore how space-based manufacturing could inspire entirely new forms of art and design, pushing the boundaries of creativity in ways we've never imagined. Now, let's turn our attention to a realm where creativity meets innovation: the intersection of space-based manufacturing and art and design. Imagine a world where the boundaries of artistic expression are no longer confined by gravity, where the unique conditions of space unlock entirely new possibilities for creativity. This isn't just about making art, it's about redefining what art and design can be in an environment where the rules are completely different. One of the most exciting prospects is the creation of sculptures and artworks in zero gravity. On Earth, gravity limits the shapes and structures artists can create, but in space, materials can float freely, allowing for forms that are impossible to achieve on the ground. Imagine intricate, flowing sculptures that seem to defy physics, or massive installations that stretch in every direction without the need for supports. These pieces wouldn't just be visually stunning, they'd challenge our understanding of art itself, pushing the boundaries of what's possible. But it's not just about aesthetics. Space-based manufacturing could also revolutionize architectural design. In microgravity, architects and engineers could experiment with entirely new building techniques and materials, creating structures that are both functional and breathtaking. Picture habitats with sweeping, organic shapes that maximize space and efficiency, or modular designs that can be easily assembled and reconfigured in orbit. These innovations wouldn't just be limited to space, they could inspire new approaches to architecture on Earth, leading to more sustainable and adaptable buildings. The impact of space-based art and design could extend beyond physical creations. Virtual reality and digital art could also benefit from the unique conditions of space. Artists could use zero-gravity environments to create immersive experiences that transport viewers to entirely new worlds, blending the physical and digital in ways we've never seen before. Imagine stepping into a virtual gallery where the art responds to your movements, or exploring a digital landscape that feels as real as the world around you. As we look to the future, the possibilities for space-based art and design are as limitless as space itself. From gravity-defying sculptures to groundbreaking architectural innovations, the fusion of creativity and technology in space could inspire a new era of artistic expression. By embracing the unique opportunities of microgravity, we can unlock a world of creativity that challenges our imagination and redefines what it means to create. Next, we'll explore how space-based manufacturing could transform the way we travel, paving the way for next-generation spacecraft and propulsion systems. Now, let's shift gears and explore how space-based manufacturing could revolutionize the way we travel beyond Earth. Picture this. A future where spacecraft and propulsion systems are not just built in orbit, but are designed to take us farther and faster than ever before. This isn't just about improving existing technology, it's about reimagining the very foundation of space travel. One of the most exciting possibilities is the production of next-generation spacecraft in microgravity. On Earth, the construction of large spacecraft is limited by gravity and the need for massive launch systems. But in space, we could assemble enormous, lightweight structures that are impossible to build on the ground. Imagine spacecraft with expansive solar sails, sleek designs optimized for zero gravity, and modular components that can be easily upgraded or repaired in orbit. These advancements wouldn't just make space travel more efficient, they'd open up entirely new possibilities for exploration. Propulsion systems are another area where space-based manufacturing could make a huge impact. Traditional rocket engines are heavy, complex, and limited by the physics of Earth's atmosphere. But in space, we could develop entirely new propulsion technologies, such as ion drives or even nuclear-powered engines that are lighter, faster, and more sustainable. These systems could drastically reduce travel times within our solar system, making missions to Mars, the outer planets, and beyond more feasible than ever before. But the benefits don't stop there. Space-based manufacturing could also enable the creation of reusable spacecraft on a scale we've never seen. Imagine fleets of vehicles that are built, maintained, and refueled in orbit, ready to transport people and cargo between planets with ease. This would not only lower the cost of space travel, but also make it more accessible, paving the way for a thriving interplanetary economy. As we look to the future, the potential for space-based transportation manufacturing is truly staggering. From faster propulsion systems to reusable spacecraft, the innovations made possible by microgravity could transform how we explore and inhabit our solar system. And with each new advancement, we move one step closer to a future where the stars are no longer out of reach. Next, we'll dive into how space-based manufacturing could play a crucial role in monitoring and protecting our planet's environment. Now, let's turn our attention to how space-based manufacturing could play a vital role in protecting our planet. Imagine a future where advanced satellites and sensors built in orbit provide real-time data on Earth's environment and climate. These tools could revolutionize the way we monitor and respond to environmental challenges, offering insights that are simply impossible to achieve from the ground alone. One of the most significant advantages of space-based manufacturing is the ability to produce highly specialized satellites designed for environmental monitoring. In microgravity, we can create larger, more precise instruments that are free from the distortions caused by Earth's atmosphere. These satellites could track everything from deforestation and ocean temperatures to air quality and greenhouse gas emissions with unparalleled accuracy. By having a constant global view of our planet, we could detect changes in the environment faster and take action before problems escalate. Another exciting possibility is the development of next-generation sensors that can be integrated into these satellites. Space-based manufacturing allows for the creation of ultra-sensitive detectors capable of measuring even the smallest changes in Earth's ecosystems. For example, sensors could monitor the health of coral reefs, track the movement of pollutants in the atmosphere, or even predict natural disasters like hurricanes and wildfires. This level of detail would provide scientists and policymakers with the data they need to make informed decisions and implement effective solutions, but the benefits don't stop at monitoring. Space-based manufacturing could also enable the production of satellites equipped with advanced communication systems, allowing them to share data instantly with researchers, governments, and even the public. Imagine a world where anyone, anywhere, can access real-time information about their local environment, empowering communities to take action and hold leaders accountable for environmental policies. As we look to the future, the potential for space-based environmental monitoring is immense. From tracking climate change to predicting natural disasters, the innovations made possible by space-based manufacturing could help us protect our planet in ways we've never imagined. And with each new advancement, we move closer to a future where humanity and nature can thrive together. Next, we'll explore how space-based manufacturing could transform education and research, opening up new frontiers for learning and discovery. Now, let's shift our focus to how space-based manufacturing could revolutionize education and research, opening up entirely new possibilities for learning and discovery. Imagine a future where cutting-edge research facilities and educational platforms are built in orbit, offering scientists, students, and innovators access to environments that simply can't be replicated on Earth. These space-based hubs could become the epicenters of groundbreaking discoveries, fostering collaboration on a global scale. One of the most exciting prospects is the creation of microgravity research labs. In space, scientists can conduct experiments free from the constraints of Earth's gravity, leading to breakthroughs in fields like materials science, biology, and physics. For example, researchers could study how cells behave in zero gravity, unlocking new insights into human health and disease. Or they could develop advanced materials with unique properties, such as ultra-strong alloys or superconductors, that could transform industries back on Earth. Space-based manufacturing also opens the door to educational platforms that bring the wonders of space directly to classrooms around the world. Imagine students participating in live experiments conducted in orbit or using virtual reality to explore the International Space Station from their desks. These immersive experiences could inspire the next generation of scientists, engineers, and explorers, sparking curiosity and creativity in ways that traditional education simply can't match. Another key advantage is the potential for international collaboration. Space-based research facilities could serve as neutral ground where scientists from different countries work together on shared goals, such as combating climate change or advancing medical research. By pooling resources and expertise, humanity could tackle some of its greatest challenges more effectively than ever before. And let's not forget the role of artificial intelligence in these space-based hubs. AI could analyze vast amounts of data collected from experiments, identifying patterns and insights that might otherwise go unnoticed. This could accelerate the pace of discovery, leading to faster solutions for problems like energy sustainability, food security, and even space exploration itself. As we look ahead, the possibilities for space-based education and research are truly limitless. From groundbreaking experiments to inspiring the next generation of innovators, the advancements made possible by space-based manufacturing could reshape how we learn, discover, and collaborate. And with each new development, we move closer to a future where the boundaries of knowledge are pushed further than ever before. Next, we'll explore how space-based manufacturing could give rise to entirely new forms of entertainment, transforming how we experience fun and creativity beyond Earth. Now, let's take a leap into the future of fun and creativity as we explore how space-based manufacturing could revolutionize entertainment. Picture this: zero-gravity sports arenas where athletes defy the laws of physics, soaring through the air in ways that would be impossible on Earth. Imagine spectators watching from orbital platforms, cheering as players perform gravity-defying feats in games that blend athleticism with the thrill of space exploration. These arenas could host everything from zero-gravity basketball to entirely new sports designed specifically for microgravity, creating a whole new category of entertainment that captivates audiences worldwide. But it doesn't stop there. Space-based manufacturing could also give rise to immersive virtual reality experiences that are truly out of this world. Imagine strapping on a VR headset and stepping into a virtual environment created in orbit, where the absence of gravity allows for unprecedented levels of realism and interactivity. You could explore alien landscapes, participate in space missions, or even attend concerts held in zero-gravity venues, all from the comfort of your home. These experiences wouldn't just entertain, they'd inspire, offering a glimpse into the limitless possibilities of life beyond Earth. Another exciting possibility is the production of films and media in space. Imagine blockbuster movies filmed on location in orbit, with actors performing stunts and scenes that take full advantage of microgravity. Directors could create visually stunning sequences that push the boundaries of storytelling, while audiences enjoy a cinematic experience that feels truly futuristic. Space-based studios could also produce documentaries and educational content, bringing the wonders of the cosmos to screens everywhere. And let's not forget about the potential for space tourism to intersect with entertainment. Luxury spacecraft designed for leisure could offer onboard theaters, gaming lounges, and even live performances, turning the journey itself into an unforgettable experience. Imagine watching a play or concert while floating in zero gravity, or participating in a space-themed escape room as your spacecraft orbits the planet. These innovations could redefine what it means to be entertained, blending adventure with creativity in ways that were once the stuff of science fiction. As we look to the future, the rise of space-based entertainment promises to transform how we experience fun, art, and culture. From gravity-defying sports to immersive virtual worlds, the possibilities are as vast as the cosmos itself. And with each new development, we move closer to a future where entertainment isn't just about watching or playing, it's about experiencing the extraordinary. Next, we'll delve into how space-based manufacturing could play a crucial role in enhancing defense and security, ensuring a safer future for humanity both on Earth and beyond. Now, let's shift our focus to a critical aspect of humanity's future in space: defense and security. As we venture further into the cosmos, the need to protect our assets, both on Earth and in orbit, becomes increasingly important. Space-based manufacturing could play a pivotal role in developing advanced defense systems that ensure safety and stability in this new frontier. One of the most exciting possibilities is the creation of satellite shields. These protective structures, manufactured in space, could safeguard critical satellites from space debris, micrometeoroids, and even potential threats from hostile entities. Imagine a network of orbiting shields designed to absorb impacts and deflect hazards, ensuring that communication, navigation, and observation satellites remain operational. This technology wouldn't just protect infrastructure, it could also prevent catastrophic collisions that might otherwise disrupt global services. Beyond shielding, space-based manufacturing could enable the production of advanced surveillance systems. Orbiting platforms equipped with high-resolution sensors and artificial intelligence could monitor Earth and space in real time, providing unparalleled situational awareness. These systems could detect everything from natural disasters to unauthorized spacecraft, offering early warnings and actionable intelligence. For example, they could track the movement of asteroids, monitor climate changes, or even identify potential security threats, giving governments and organizations the tools they need to respond swiftly and effectively. Another groundbreaking application is the development of space-based defense platforms. These could include autonomous drones or robotic systems designed to patrol and protect key orbital zones. Manufactured in space, these platforms will be optimized for the unique challenges of the environment, such as microgravity and radiation. They could serve as a first line of defense, deterring threats and ensuring the safety of both space-based infrastructure and Earth itself. Space-based manufacturing could also revolutionize the way we approach cybersecurity in space. As our reliance on orbital systems grows, so does the risk of cyber attacks targeting satellites and other critical infrastructure. By producing secure, tamper-proof hardware in the controlled environment of space, we could reduce vulnerabilities and create more resilient systems. This would not only protect data and communications, but also ensure the integrity of essential services like GPS and weather monitoring. As we look to the future, the integration of space-based manufacturing into defense and security strategies promises to create a safer, more secure world. From satellite shields to advanced surveillance, these innovations could redefine how we protect our planet and our presence in space. Next, we'll explore how space-based manufacturing could transform global communication, paving the way for faster, more reliable networks that connect us like never before. Now, let's turn our attention to how space-based manufacturing could revolutionize the way we communicate, not just on Earth but across the solar system. Imagine a world where internet access is seamless, no matter where you are, whether you're in a remote village, on a ship in the middle of the ocean, or even on a future Mars colony. This is the promise of space-based communication infrastructure, and it all starts with manufacturing in orbit. One of the most transformative applications is the production of next-generation satellite constellations. These aren't your average satellites, they're advanced, high-capacity systems designed to deliver global satellite internet. Built in space, these satellites can be larger, more efficient, and more durable than anything we could launch from Earth. Picture a network of thousands of these satellites working together, blanketing the planet with high-speed, low-latency internet. This could bridge the digital divide, bringing connectivity to underserved regions and enabling new opportunities for education, healthcare, and economic growth. But the potential doesn't stop at Earth. Space-based manufacturing could also pave the way for interplanetary communication systems. As humanity expands its presence to the Moon, Mars, and beyond, we'll need reliable ways to stay connected. Manufacturing communication hubs in space like relay stations and deep space antennas could ensure that data travels quickly and efficiently across vast distances. These systems would be essential for coordinating missions, sharing scientific discoveries, and even staying in touch with future space colonies. Another exciting possibility is the creation of quantum communication networks. Built in the pristine environment of space, these networks could leverage the unique properties of quantum mechanics to enable ultra-secure, unhackable communication. This would be a game-changer for everything from government communications to financial transactions, offering a level of security that's simply impossible with current technology. Space-based manufacturing could also address one of the biggest challenges of modern communication: congestion. By producing satellites and infrastructure in orbit, we could reduce the need for frequent launches, minimizing space debris and freeing up valuable orbital slots. This would make space safer and more sustainable, ensuring that our communication networks remain reliable for generations to come. As we look ahead, the role of space-based manufacturing in communication infrastructure is nothing short of revolutionary. From global internet access to interplanetary networks, these innovations could connect us in ways we've only dreamed of. Next, we'll explore how space-based manufacturing could play a vital role in disaster relief, providing rapid solutions when Earth needs them most. Now, let's shift our focus to a critical application of space-based manufacturing that could save lives and rebuild communities in times of crisis. Picture this: a devastating earthquake strikes a densely populated city, leaving thousands without shelter, clean water, or medical supplies. On Earth, the logistics of delivering aid can be slow and complicated. But what if we could produce emergency supplies and infrastructure directly in space, ready to deploy at a moment's notice? This is the promise of space-based disaster relief. By leveraging the unique capabilities of orbital manufacturing, we could rapidly produce essential items like modular shelters, water purification systems, and medical equipment. These supplies could be manufactured in space using advanced materials and techniques, then transported back to Earth in compact, lightweight forms that are easy to deploy. Imagine prefabricated housing units that unfold like origami upon arrival, or portable water filters that can be air-dropped into disaster zones. Space-based manufacturing could make these solutions faster, more efficient, and more scalable than ever before. One of the most exciting possibilities is the production of temporary infrastructure, such as bridges, roads, and communication towers, using materials mined from asteroids or the Moon. These structures could be manufactured in orbit and delivered to disaster-stricken areas, providing immediate support while long-term rebuilding efforts are underway. For example, a collapsed bridge could be replaced within days, restoring access to isolated communities and enabling rescue teams to reach those in need. Space-based manufacturing could also revolutionize the way we respond to natural disasters by enabling the rapid production of satellites tailored to specific crises. In the aftermath of a hurricane or flood, custom-built satellites could be manufactured and launched to provide real-time data on affected areas, helping emergency responders prioritize their efforts and allocate resources more effectively. These satellites could also support communication networks, ensuring that rescue teams and survivors can stay connected even when terrestrial infrastructure is damaged or destroyed. Another game-changing application is the production of advanced medical supplies in space. Microgravity environments allow for the creation of ultra-pure pharmaceuticals and medical devices that are difficult or impossible to produce on Earth. In a disaster scenario, these life-saving supplies could be manufactured in orbit and delivered to affected areas, providing critical support to hospitals and clinics overwhelmed by the crisis. The potential of space-based disaster relief extends beyond immediate response efforts. By producing durable, sustainable infrastructure in space, we could also help communities rebuild stronger and more resilient than before. For instance, space-manufactured materials could be used to construct earthquake-resistant buildings or flood-resistant roads, reducing the impact of future disasters. As we look to the future, the role of space-based manufacturing in disaster relief is both inspiring and essential. From rapid production of emergency supplies to the creation of resilient infrastructure, these innovations could transform the way we respond to crises, saving lives and rebuilding communities with unprecedented speed and efficiency. Next, we'll explore how space-based manufacturing could preserve Earth's cultural heritage, creating a lasting legacy for generations to come. Now, let's turn our attention to a future where humanity's greatest treasures are safeguarded among the stars. Imagine a world where the art, literature, and history of our planet are preserved not just on Earth, but in space-based archives and museums protected from the ravages of time, natural disasters, and human conflicts. This is the vision of space-based cultural preservation, a bold and inspiring application of space-based manufacturing that could ensure our legacy endures for generations to come. In this future, orbital facilities could house vast collections of digital and physical artifacts, from ancient manuscripts and priceless paintings to recordings of languages and traditions that might otherwise be lost. These space-based archives will be designed to withstand the test of time, using advanced materials and technologies to protect their contents from radiation, temperature fluctuations, and other hazards of the space environment. By storing these treasures in orbit, we could create a permanent, off-world backup of Earth's cultural heritage, ensuring that even in the face of catastrophic events, humanity's story would remain intact. One of the most exciting possibilities is the creation of space-based museums where visitors from Earth, or even future space colonies, could experience the richness of our planet's history and creativity. Picture a museum floating in microgravity, where sculptures and artifacts are displayed in ways that would be impossible on Earth, offering a truly unique and immersive experience. These museums could also serve as educational hubs, inspiring future generations to explore and appreciate the diversity of human culture. Space-based cultural preservation could also play a crucial role in protecting endangered heritage. For example, artifacts from regions threatened by war, climate change, or natural disasters could be digitized or physically transported to orbital archives, ensuring their survival even if the originals are lost. This approach would not only preserve the artifacts themselves, but also the stories, traditions, and identities they represent, creating a lasting connection to our shared past. Moreover, space-based archives could serve as a unifying force for humanity, reminding us of our common heritage and the importance of preserving it. By placing these treasures beyond the reach of terrestrial conflicts, we could create a symbol of hope and resilience, demonstrating our ability to rise above division and work together to protect what matters most. As we look to the stars, the idea of space-based cultural preservation offers a powerful reminder of what we stand to lose and what we stand to gain. By safeguarding our heritage in orbit, we could ensure that the art, history, and knowledge of our planet endure, inspiring future generations to build on the legacy we leave behind. Next, we'll explore how space-based manufacturing could play a role in addressing one of humanity's greatest challenges, climate change. Now, let's shift our focus to a future where space-based manufacturing could play a pivotal role in addressing one of humanity's most pressing challenges, climate change. Imagine a world where we harness the power of space to engineer solutions that protect our planet from the escalating threats of global warming. This is the promise of space-based climate engineering, a bold and innovative approach that could reshape our relationship with Earth's environment. One of the most ambitious ideas in this realm is the creation of solar shields, massive structures deployed in space to reflect a portion of the sun's rays away from Earth. These shields, constructed using advanced materials and techniques developed through space-based manufacturing, could help regulate global temperatures by reducing the amount of solar energy that reaches our planet. Picture vast arrays of lightweight, reflective panels orbiting in space, strategically positioned to counteract the effects of greenhouse gases and slow the pace of climate change. But solar shields are just the beginning. Space-based manufacturing could also enable the production of other climate engineering tools, such as orbital mirrors or dust clouds designed to scatter sunlight. These technologies, built and deployed in the unique conditions of space, could offer precise and scalable solutions to mitigate the impacts of global warming. By leveraging the resources and capabilities of space-based manufacturing, we could create systems that are not only effective but also sustainable, minimizing the environmental footprint of their construction and operation. Another exciting possibility is the use of space-based platforms to monitor and manage Earth's climate in real time. Advanced satellites and sensors manufactured in orbit could provide unprecedented insights into weather patterns, carbon levels, and other critical data. This information could then be used to fine-tune climate engineering efforts, ensuring they are as effective and efficient as possible. Imagine a network of orbital observatories working in harmony to safeguard our planet's future. Space-based climate engineering also opens the door to international collaboration on a scale never seen before. By pooling resources and expertise, nations around the world could work together to develop and deploy these technologies, creating a shared commitment to protecting our planet. This collaborative approach could not only accelerate progress but also foster a sense of global unity in the face of a common challenge. As we look to the stars, the potential of space-based climate engineering offers a glimmer of hope in the fight against global warming. By combining the ingenuity of space-based manufacturing with the urgency of climate action, we could create a future where humanity thrives in harmony with its environment. Next, we'll venture even further into the cosmos, exploring how space-based manufacturing could enable the production of interstellar probes designed to unlock the mysteries of distant star systems. Now, let's take a leap beyond our solar system and into the vast expanse of the cosmos. Imagine a future where space-based manufacturing enables us to build interstellar probes, sophisticated spacecraft designed to travel to distant star systems and uncover the secrets of the universe. These probes, constructed in the unique environment of space, could revolutionize our understanding of the cosmos and potentially answer one of humanity's most profound questions: are we alone? The production of interstellar probes in orbit offers several advantages over traditional Earth-based manufacturing. In the microgravity of space, we can create spacecraft with ultra-lightweight yet incredibly durable materials, allowing them to travel faster and farther than ever before. Picture probes made from advanced alloys and composites, engineered to withstand the extreme conditions of interstellar space, cosmic radiation, micrometeoroid impacts, and the vacuum of deep space. These materials, impossible to produce on Earth, could give interstellar probes the resilience needed for journeys lasting decades or even centuries. But it's not just about durability. Space-based manufacturing could also enable the integration of cutting-edge technologies into these probes. Imagine spacecraft equipped with next-generation propulsion systems, such as solar sails or ion drives, capable of reaching speeds that bring distant star systems within our reach. These propulsion systems, built and tested in orbit, could drastically reduce travel times, making interstellar exploration a tangible reality. Another exciting possibility is the inclusion of advanced scientific instruments manufactured in space with unparalleled precision. These instruments could analyze the atmospheres of exoplanets, search for signs of water or organic molecules, and even detect potential signals from extraterrestrial civilizations. By leveraging the unique conditions of space-based manufacturing, we could produce sensors and detectors far more sensitive and accurate than anything built on Earth. The construction of interstellar probes in orbit also opens the door to modular design, where components can be assembled and tested in space before being launched on their epic journeys. This approach would allow for greater flexibility and innovation, as engineers could continuously refine and upgrade probe designs without the constraints of Earth's gravity and atmosphere. Imagine a future where interstellar probes are built like cosmic puzzles, with each piece meticulously crafted and assembled in the void of space. As we look to the stars, the potential of space-based manufacturing to enable interstellar exploration is nothing short of transformative. These probes could be our eyes and ears in the cosmos, venturing into uncharted territories and sending back data that reshapes our understanding of the universe. From the search for extraterrestrial life to the exploration of habitable exoplanets, interstellar probes represent the next frontier in humanity's quest to explore the unknown. Next, we'll delve into how space-based manufacturing could enhance human capabilities, paving the way for technologies that augment our physical and cognitive abilities as we venture further into the cosmos. Now, let's shift our focus from the vastness of interstellar exploration to the incredible potential of enhancing human capabilities through space-based manufacturing. Imagine a future where the unique conditions of space enable the creation of advanced technologies designed to augment our physical and cognitive abilities, equipping us to thrive in the challenges of space exploration and beyond. One of the most exciting possibilities is the development of space-manufactured prosthetics. In the microgravity environment of space, we can produce prosthetics with unprecedented precision and functionality. Picture lightweight, ultra-durable limbs engineered with advanced materials that mimic the strength and flexibility of natural human limbs. These prosthetics, crafted in orbit, could offer enhanced mobility and dexterity, allowing astronauts to perform complex tasks with ease during long-duration missions or on the surfaces of other planets. But it doesn't stop there. Space-based manufacturing could also revolutionize neural interfaces, devices that connect the human brain directly to machines or computers. Imagine neural interfaces produced in the pristine conditions of space, free from Earth's contaminants and gravitational distortions. These interfaces could enable seamless communication between astronauts and their spacecraft, allowing for real-time control of robotic systems or even the ability to remotely operate equipment on distant planets. Such technology could drastically improve mission efficiency and safety, reducing the risks associated with human error. Another groundbreaking application is the enhancement of human endurance and resilience. Space-manufactured exoskeletons, for example, could provide astronauts with additional strength and support, enabling them to carry heavy equipment or perform physically demanding tasks in low-gravity environments. These exoskeletons, designed with cutting-edge materials and integrated with neural interfaces, could adapt to the user's movements, offering a natural extension of their body. Beyond physical augmentation, space-based manufacturing could also lead to advancements in cognitive enhancement. Imagine neural implants produced in space, capable of boosting memory, focus, and problem-solving abilities. These implants could help astronauts process vast amounts of information quickly, making critical decisions during high-stakes missions. By enhancing both physical and cognitive capabilities, space-manufactured technologies could transform humans into more capable explorers, ready to tackle the challenges of deep space. The potential of space-based human augmentation extends far beyond space exploration. These technologies could also have profound implications for life on Earth, offering new solutions for individuals with disabilities or those recovering from injuries. By leveraging the unique conditions of space, we could unlock innovations that enhance human potential in ways we've only begun to imagine. As we look to the future, the integration of space-based manufacturing and human augmentation represents a bold step forward in our journey to explore the cosmos. These advancements could redefine what it means to be human, empowering us to push the boundaries of exploration and discovery like never before. Next, we'll explore how space-based manufacturing could pave the way for terraforming technologies, transforming barren worlds into habitable environments for future generations. Now, let's turn our attention to one of the most ambitious applications of space-based manufacturing, terraforming technologies. Imagine a future where we don't just explore other planets, but actively transform them into livable worlds for humanity. This is where space-based manufacturing could play a pivotal role, enabling the creation of tools and systems designed to reshape entire planets. One of the key challenges of terraforming is the sheer scale of the task. To make a planet like Mars habitable, we would need to alter its atmosphere, temperature, and surface conditions to support human life. Space-based manufacturing could provide the means to produce massive atmospheric processors machines designed to release greenhouse gases or other compounds into a planet's atmosphere, gradually warming it and creating conditions suitable for liquid water. These processors, built in orbit using materials harvested from asteroids or the Moon, could be deployed to other planets and operated remotely, kickstarting the terraforming process. Another critical component of terraforming is the production of bioengineered organisms. In space-based facilities, scientists could develop microorganisms capable of surviving and thriving in harsh planetary environments. These organisms could be designed to produce oxygen, break down toxic compounds, or even create fertile soil from barren rock. By manufacturing these organisms in the controlled conditions of space, we could ensure their effectiveness and safety before introducing them to a target planet. Space-based manufacturing could also enable the creation of massive solar mirrors or shades. These structures, assembled in orbit, could be positioned to reflect sunlight onto a planet's surface, increasing its temperature, or to block sunlight, cooling it down. By precisely controlling the amount of light reaching a planet, we could regulate its climate and create more stable conditions for terraforming efforts. Water is another essential resource for terraforming, and space-based manufacturing could help us extract and deliver it to other planets. Imagine robotic systems built in orbit, designed to mine water from icy moons or asteroids and transport it to terraforming sites. These systems could also produce water from hydrogen and oxygen harvested in space, ensuring a steady supply for future colonies. The production of durable construction materials in space would also be crucial for building the infrastructure needed to support terraforming. From habitats and greenhouses to energy systems and transportation networks, space-based manufacturing could provide the tools to construct entire ecosystems on other planets. These materials, engineered to withstand extreme conditions, would form the backbone of a new, habitable world. Terraforming is not just about making other planets livable, it's about expanding the possibilities for humanity's future. By leveraging space-based manufacturing, we could take the first steps toward transforming barren worlds into thriving environments, opening up new frontiers for exploration and settlement. This vision of the future is not just science fiction, it's a tangible goal that space-based technologies could help us achieve. As we look ahead, the potential of space-based terraforming technologies reminds us of the boundless creativity and ingenuity of humanity. These advancements could redefine our relationship with the cosmos, turning distant planets into new homes for future generations. Next, we'll explore how space-based manufacturing could lay the foundation for universal basic infrastructure, supporting a thriving interplanetary civilization. Now, let's shift our focus to a concept that could redefine how humanity operates beyond Earth: universal basic infrastructure in space. Imagine a future where shared manufacturing hubs and resource distribution networks form the backbone of an interplanetary civilization, ensuring that every colony, spacecraft, and outpost has access to the tools and materials they need to thrive. This vision of space-based universal basic infrastructure isn't just about survival, it's about creating a sustainable and interconnected system that supports growth and innovation across the solar system. At the heart of this concept are shared manufacturing hubs, strategically placed in orbit around Earth, the Moon, and other key locations. These hubs would serve as central points for producing essential goods, from construction materials to advanced electronics, using resources harvested from asteroids, the Moon, and other celestial bodies. By pooling resources and manufacturing capabilities, these hubs could reduce costs, minimize waste, and ensure a steady supply of critical items for all space-based operations. Think of them as the interplanetary equivalent of global supply chains, but optimized for the unique challenges of space. Resource distribution networks would complement these manufacturing hubs, creating a seamless flow of materials and products across vast distances. Advanced propulsion systems and autonomous spacecraft could transport goods between hubs, colonies, and exploration missions, ensuring that no outpost is left without the resources it needs. These networks would rely on space-based manufacturing to produce the ships, fuel, and infrastructure required to keep the system running efficiently. Over time, this interconnected web of production and distribution could grow to support not just a few colonies, but an entire interplanetary economy. One of the most exciting aspects of universal basic infrastructure is its potential to democratize access to space. By creating shared resources and manufacturing capabilities, we could lower the barriers to entry for smaller nations, private companies, and even individual explorers. Instead of each group needing to develop their own infrastructure from scratch, they could tap into a network of shared facilities, accelerating progress and fostering collaboration. This approach would not only make space exploration more accessible, but also encourage innovation as diverse groups bring their unique perspectives and ideas to the table. Space-based universal basic infrastructure could also play a crucial role in sustainability. By centralizing manufacturing and resource management, we could minimize the environmental impact of space activities, reducing the need for repeated launches from Earth and ensuring that resources are used efficiently. Recycling systems powered by space-based manufacturing could turn waste into valuable materials, creating a closed-loop economy that supports long-term growth without depleting finite resources. This sustainable approach would be essential for building a civilization that can thrive in space for generations to come. As we look to the future, the concept of universal basic infrastructure in space offers a compelling vision of what humanity could achieve when we work together. By creating shared systems that support exploration, innovation, and sustainability, we could lay the foundation for a thriving interplanetary civilization. This isn't just about building habitats or producing goods. It's about creating a framework that enables humanity to reach its full potential in the cosmos. And with space-based manufacturing at the core of this vision, the possibilities are truly limitless. With this final prediction, we've explored how space-based manufacturing could transform not just how we build and explore, but how we live and thrive as a species. From zero-gravity 3D printing to universal basic infrastructure, these advancements remind us that the future of space is not just about technology, it's about the boundless potential of human ingenuity. As we wrap up this journey through the future of space-based manufacturing, it's clear that the possibilities are as vast as the cosmos itself. From zero-gravity 3D printing enabling the creation of unimaginable structures, to in-situ resource utilization turning asteroids into raw materials, and orbital factories revolutionizing industries on Earth and beyond, each prediction paints a picture of a future where humanity's reach extends far beyond our planet. We've explored how space-based solar power could provide limitless clean energy, how self-replicating machines could accelerate our expansion into the stars, and how space-grown materials could unlock breakthroughs in medicine and technology. The potential for space-based pharmaceutical production, space construction robots, and advanced recycling systems shows us a future where sustainability and innovation go hand in hand. And with concepts like universal basic infrastructure in space, we've seen how shared resources and collaboration could pave the way for a thriving interplanetary civilization. These 30 predictions aren't just about technology, they're about the incredible potential of human creativity and determination. They remind us that the challenges of space are not barriers, but opportunities to push the boundaries of what's possible. Whether it's building space-based entertainment industries, developing advanced defense systems, or creating tools for terraforming other planets, each idea represents a step toward a future where humanity becomes a multi-planetary species. And at the heart of it all is space-based manufacturing, the engine that will drive this transformation, turning science fiction into reality. So, what do you think? Could you see yourself contributing to this exciting frontier? Whether you're an engineer, a scientist, an artist, or simply someone with a passion for the future, there's a role for everyone in shaping this new chapter of human history. The future of space-based manufacturing isn't just something to imagine, it's something we can all help build. If you're as inspired by these ideas as we are, don't forget to hit that like button, subscribe to the channel, and ring the notification bell so you never miss an update on the latest in futuristic technologies. Together, let's dream big, explore boldly, and create a future that's truly out of this world.